Today I want to show you how to add a display to your JNIOR controller. In this case, it's not just a display, but this device has a keypad. So it's a HMI, Human Machine Interface. You can not only control what's displayed here using the JNIOR, but you can have keypad input, control and change what you see, or alter how the JNIOR does its job. Now, making the connection between these two is pretty straightforward. It's just a serial connection. So I'm going to get into the details of that in this video. And subsequently, we'll look back at what's involved in programming the JNIOR to communicate with this device. Actually, those program steps, depending on how complex the interaction needs to be with an external display, those steps aren't too difficult to do at all. But today, we're just going to concern ourselves with the hardware and how exactly to make the connection. You'll find it's pretty simple to do that, but at the same time, you want to make sure that your hardware is done cleanly so that the device can be placed into an application and look professional. Now, this display is one of many available on the internet. We selected this one for another application because, first of all, it's very synergistic with the JNIOR in the sense that the JNIOR has a nice dark black housing, and so does this model display. The JNIOR uses even white contrasted against the black, as this display does. Display is also very useful in the sense that, you know, there's quite a bit you can do with this arrangement of keypad. And then over here, there are 3 LEDs that can be either off, red, green, or yellow. And so those are additional indicators that are available for the application. It doesn't take very long once you've got the JNIOR program to control relays and do your basic functionality. That it doesn't take too long after that for you to want to tweak things and add a little bit more information and get the display to work. And suddenly you want to provide the user or anyone in the area with more status, and you know, the more flexibility you have with this, the more professional and complete the application can be. And it's not that expensive to do this. Now, I'm sure our friends up north in Canada are happy because I'm basically giving them an ad right here. This display is from Matrix Orbital. You can get this display with or without the case, just a display with the keypad. There's a lot of flexibility. You want to select the one with the serial interface. There's one that has graphics display. So talk to them, Matrix Orbital, and perhaps there's a different model more appropriate for your application. But let's look at the connection. First, I'm going to power down the JNIOR by removing the transformer and disconnect the display from the JNIOR. Put this aside. The display needs a source of power, and we get that from the power connector and the power supply to the JNIOR, and we'll talk about that in some length in a minute. Let's remove the JNIOR supply from the picture right at this point. Okay, so here we have this display. It's a serial cable I've constructed like this. Display. In fact, one thing nice about this display too is it's got a 1/4-20 mount in the center, so you can put this on a tripod or a small tripod-like clip, so you can clip this to the side of a table or onto a mounting surface. Okay, I didn't think you needed to see me go through the effort of loosening all 4 screws. And inside, as I mentioned, you can buy this without the housing. You can see there's the serial connection is made here, and we've got an arrangement here that we'll talk about now. Let's go over to the desktop, and I can show you this cable in a bit more detail. Here's the drawing that I made for this. Now you would recognize the circuit boards here and the connector, this one right here, that that we're talking about. So let's go through this. Our target is the serial connection on the JNIOR. That requires a male DB9 connector, and you can get a hood for it. The serial communications requires a 3-wire interface. That's a wire for transmit, a wire for receive, and a wire for ground. Those 3 signals get connected directly to the board. Pin 4, this one here, is ground. That would be this screw right here. The closest one to the center of the display is ground. And this is the only tricky connection because we're going to use that one for 3 individual connections. There's a wire to that from the cable. There are 2 wires actually to that from the cable and 1 from this rectangular device, which we'll talk about momentarily. So there are 3 wires being captured in that 1 screw terminal. And the wires do fit. 4th one, I'm not sure it will, but a 3 do, and they can be clamped quite tightly. So you see here, there are the 3 wires. But relative to the serial communications channel, pin 5 is ground, and that goes to pin 4 here. To receive is the blue wire, and the blue wire goes to pin or terminal 3. And pin 2 is transmit, and that is the brown wire, and this particular brown wire comes right here to pin 2. That leaves one more connection to the display, which is power. Now, this device comes with a warning because it operates on 5 volts. In fact, when you get the package, there's a sticker right here that says caution, 5-volt power only, improper power up will void warranty. And there's warnings everywhere. And that's interesting because, you know, we actually are using with the JNIOR 12 volts. So that's where this device comes into play. So we actually have a power DC-DC converter, which is a LDO power regulator, I'm sure, in an encapsulated package that will accept 12 volts from our external power and make sure that it supplies only 5 volts to the display. Now, what is that device? Well, first of all, you can see how it's wired in here. I'm going to pick up our 12 volts right here on this red and white wire. And when, of course, the white wire is ground, and we tied it together with the green wire on pin 4 inside here, right there on that pin. And the black wire, the center one from this DC-to-DC converter, is also ground and tied there. So those are the 3 wires, again, that are captured by that 1 pin. Okay. The red wire from the DC-to-DC converter happens to be connected directly to the red wire we're using in the cable, which then comes out here and will pick up the 12 volts. And the brown wire from the DC-to-DC converter, which is the output, positive 5 volts, will then go to pin 1 to power the display. So in this manner, we can provide DC power from 7 to 32 volts and be comfortable that we are going to power the matrix orbital display with the 5 volts that they hope that we would be using. And it's nice because it's a small device and it fits inside the housing. In fact, you can get these readily from DigiKey, and the part number, DigiKey part number is 9452202, and they run $8 $8 or so for onesie twosies. Not too bad considering the advantage it gives you. This is a much better approach than trying to use a separate 5-volt supply for the display and plugging that into the AC outlet right next to the 12-volt transformer for the Junior. We can look at the data sheet and see that Recom DC-DC converter, this is the model number that we're using right here, is the R705 78W5.0-05, and it provides, if I can highlight this nicely, here you go, it provides 5 volts out at a 0.5 amp for inputs from 6.5, that's why I said 7 before, to 32 volts, and that encapsulates nicely the range of supply requirements for the Junior. So whatever you're using for the Junior, provided it's DC, can power this, and you'll get 5 volts for the display. So going back to the wiring, you can see how we're using this. Now I have 6-wire cable, so the black connection wire through the cable is not being used. It can be just cut. And the shield, as you know, many of you know that the shield is there, should not be connected at both ends. You can either connect it to pin 5 ground here, I just tack it on the pin, or you could connect it to the chassis ground if you had a metal hood and you connected it to the housing of the connector, but one or the other, but not both, and connected at this end and not this end. And that gives you this arrangement. Now we'll put that back in the housing. You can, you see how there's room for this inside here. That underneath this hood. There's a space here for the cable to come out. This cable fits out nicely. What I would recommend you doing if you're going to install this in the field and it's not going to be affixed so that there might be some stress, strain, or someone yanks on the cable, you can put a tie wrap right here and prevent that from being pulled out and this being any force being applied on these connections in that manner. And I've done that with another one of these. So let me take a moment and put this housing cover back on. Here we go. Got it back on. Simple as that. Now, what is next is making the connection to the Junior. Well, the serial connection is no big deal. We'll use the aux port here. So that's done, as you see. And we're going to connect to the power on the Junior. Let me just plug that in and power it up for a second. Junior boots. Very nice. You'll notice that there's not a barrel connector here, which is what you typically see at the end of a power transformer. It's because the Junior is sold into a lot of applications where you might use a 10 amp power supply to power a handful of these Juniors, and this would be all wired in a harness, and this type of connector is useful for that kind of thing. You can also use the Junior. It's 12 to 24 volts of DC or AC supply. And if we go take a moment and come over to the desktop, I'll show you in the circuit here that there's actually a bridge on the input side of that power supply, and this rather odd arrangement for the input allows you to use 12 volts AC, such as you might find in an HVAC, or 24 volts AC in an HVAC application, to obtain the DC power that the Junior needs to run. And you can also put DC on this, and really which side is positive and which side is negative is somewhat arbitrary. And so there's a lot of times that people will look at the negative side of the power supply and think it's ground, and it's not. So this is a topic for another discussion. But you will notice that pins 1 and 2 are connected, bridged together, and pins 3 and 4 are bridged together on that 4-pin connector. One side is considered to be positive, the other side is considered to be negative. In fact, I had here briefly, you can actually see if you look at the bottom of the board where those 2 pins are interconnected. So if we tighten in on this a little bit, you'll see that there's positive and negative markings here, but that is really kind of an arbitrary selection. And in fact, if you happen to miswire this so that this side was positive and this side was negative, the JNIOR would still work. So before we hook up our display, we're going to take a moment just to make sure that I've wired my JNIOR correctly, because I don't want to put reverse power on our display. So we'll just back up a little bit here and center this stuff for you. Here you go. So I'm going to measure using my meter, putting the red lead on what should be positive and the black lead on what should be minus, and make sure I've got about 12 volts positive, and I do. So this is wired correctly where that plus indication is in fact the positive lead. We would not know otherwise. Let's disconnect the JNIOR power supply and bring in our power from the module. So if I just capture this wire on this side, this is the ground wire, the white wire. Helps to actually get it in the hole. Here we go. And capture the positive lead here. Okay, so now we should have power for our display. So let's apply power. And there you go, matrix orbital. Thanks, guys. And you can see that the LEDs, in this case, are showing, they show almost green here, but they're actually, I think, in the yellow mode. So if I come over to the desktop, program, and we'll get into that later, that might display something, we can actually update the display.